Moving on to section 4.3, subspaces of vector spaces. These are more proofs, but they are much nicer. In order to prove something is a subspace, we only need to prove two things. So if you have the notes that are on e-learning, on that first page where it says test for a subspace, the two things that have to be true is that any two vectors that I add that are in the subspace, if I add them together, they stay in the subspace. And if I multiply something that is in the subspace by a scalar, it stays in the subspace. So there's only two things now we need to do, that any addition and any scalar multiplication stays in that subspace. So is it a subspace? So number one, V, my vector space, my bigger space that I'm talking about, is all ordered triples, so R3. W, I want to know, is W a subspace? And the W is the set of all ordered triples, where 0, Y, and Z is my ordered triple, such that Y and Z are elements of the real. So hopefully you remember your set notation. So this is all ordered triples, such that the first term is 0, and the second two terms can be anything that are in the real numbers. So I need to prove two things. If I add any two things in this form, it stays in this form, is my first one. So let's say I add 0YZ plus 0BC. I apologize, I don't know what just happened there. Plus 0BC. When I add that, I get 0, Y plus B, Z plus C. Well, that is in W, so that's good. It stays in the same form. Any two things I add stay in that form. All right, the second thing we need to show is scalar multiplication. So if I do K, let's just say, times 0YZ, which would be a 0. Well, K times 0, anything times 0 is still 0. KY, KZ. Well, that's still an element of W, so that's good. So both of those are true. Therefore, W is a subspace. And we're good. All right, so our second problem, what we're going to do next. So our given vector space that we're talking about, our big space, is still going to be ordered triples. But now what I want to know if it's a subspace is any ordered triple such that if I multiply my first two components, I get 0. So just like before, if it's true, I need to prove it's true for both when using variables. So that's what I did up here with my first example. I used variables to show it's true for any ordered triple in that form. So for this one, is this going to be true? Is any ordered triple in this form, if I add them or do a scalar multiple, do I still get something in that form? And the answer is no. So I need to show it's true for a very specific example. So if I take 1, 0, 0, there, if I multiply my first two terms, I get 0. Add that to 0, 1, 0. There, if I multiply the first two terms, I still get 0. Well, when I add them, I get 1, 1, 0. Well, now when I multiply my first two terms, I don't get 0. This is not a member of W. Therefore, W is not a subspace. So just like before, if it's true, show it with lots of examples. If it's not true, show it with a very specific example, a number 1. All right, so not only can we do this with vectors, we can also do it with matrices. Let me do one of those, then we'll be done with this section. All right, so number 3 is actually going to be number 5 in your notes. So if my vector space is the set of all 2 by 2 matrices, all right, and W is the set of all 2 by 2 matrices such that M is symmetric. So you need to remember what symmetric means. Symmetric means the original equals the transpose. All right, so let's look. Number 1 says if we add any two symmetric matrices, we're going to get a symmetric matrix. So let me come up with a symmetric matrix using variables A, B, B, C. This is symmetric because if I take my first row, make it my first column, it matches. If I take my second row, make it my second column, it matches. Add to that D, E, E, F. Again, if I take my first row, it matches my first column. My second row matches my second column. When I add that, I get A plus D next to B plus E over B plus E next to C plus F. Well, that is also symmetric, so that is also a member of W, so that's good. What happens if I do a scalar multiple times it? So the second thing I have to prove. So let's just go with K again, times A, B, B, C. Well, that would be KA next to KB over KB next to KC. Again, that is symmetric because my first row matches my first column, my second row matches my second column, so that is also in W. So therefore, W is a subspace. And that is it for section 4.3. So that was a fairly quick one.